In this video, I'm going to go through exactly what you need to say to score full marks on any Ohm's law question, and then we'll go through some exam questions. So our first model answer says, state what is meant by Ohm's law. So it's the current flowing through a conductor is directly proportional to the potential difference across it. That gets you 1 mark. And then you also must say, providing temperature is constant. We'll find out in a later video that temperature can affect resistance, which will therefore affect current or potential difference. So mathematically, we can say that that means that potential difference is proportional to current. And from maths, you should know that to go from proportion to an equal sign, we need a constant of proportionality. So we need V is equal to I times constant of proportionality R, which is our resistance. And I'll call that equation 7. Now, it's really important to note that in an exam, if you're ever stating a formula in an exam answer, you have to define all your key terms. So let's just say where V equals potential difference, I equals current, and R is our resistance. So what does it mean current is directly proportional to potential difference? Well, if current increases, then potential difference will increase by the same amount. So graphically, if I draw current versus potential difference on a graph, we can put current on the x-axis, potential difference on the y-axis. The graph will be a straight line, and we can see this from the formula for a straight line. From maths, you should know that y is equal to mx plus c is the equation of a straight line. We've just said that Ohm's law is V is equal to IR, but if I write it as R times I, we can see that the y value is V, the x value is I, so the gradient of the graph must be R. Now let's take a look at what an exam question would look like. The question says an electric torch uses two 1.5 volt cells. The torch bulb is marked 2.4 volts and 270 milliamps. What is the resistance of the torch bulb? Now, for any exam question, I always like to label what terms I've been given. So I have a potential difference, another potential difference, a current, and a resistance. So I have V, I, and R, which means I should use Ohm's law. Now, where this question is tricky is we're given two potential differences. So what potential difference do I use? Well, let's draw a circuit. So I have one of the 1.5 volt cells, another one. Together, they make a 3 volt battery. Then I have the bulb. Now the bulb has a potential difference of 2.4 volts. So let's draw a voltmeter to show this. And also a current of 270 milliamps. So I'm going to need to draw an ammeter in series. Now let's write out each of my terms. I know that current is the same in series. So the bulb's going to have a current of 270 milliamps. I can now see that the potential difference over the bulb is 2.4 volts. So that's the potential difference I'm going to use. I know that Ohm's law is V as IR. I can rearrange that to get R as V divided by I. I can substitute in my numbers. So I get 2.4. And then it's really important to convert the milliamps of current into amps. So I get 270 times 10 to the minus 3 amps, which is the same as 8.9 ohms. So the answer is C. Now you might be thinking, why would the potential difference across the bulb be different to the potential difference supplied by the battery? Well, there's two reasons, and I will cover these in a later video, but for now, the answer would be the battery may have an internal resistance, so some energy is lost to the internal resistance of the battery. The second reason is it does take up some energy to move through the wires. So the answer there would say the wires have resistance, so some energy is lost due to the heating effect of the wires. Now let's look at another example. I recommend you pause the video this time and have a go yourself. So the question says a cell of EMF 1.5 volts is connected to a 5 ohm resistor. The terminal potential difference across the cell is 1 volt. Which of the following is the current in the circuit? Now, just like any A-level physics question, the first step is always to label our terms. So we have EMF is the potential difference supplied by the cell, so that's just V. Connected to a 5 ohm resistor, we have another potential difference and we have a current. So we have V, I and R, which means we have to use Ohm's law. Now let's label the circuit. We have 1.5 volts here, a 5 ohm resistor. Now this point here is really important. The terminal potential difference across the cell is 1 volt. So even though the potential difference supplied by the cell is 1.5 volts, in our previous example, we learned that this doesn't always mean this is what the resistor receives. The resistor this time will receive the terminal potential difference of 1 volt. So if I drew a voltmeter across the resistor, it would show the terminal potential difference. And again, this could be due to the internal resistance of the cell. So we're going to use V as IR. I is V divided by R. If I replace the letters with numbers, I get potential difference is 1 volt because we're looking at the potential difference across the resistor, divided by 5 ohms, which gives me 0.2 amps. So the answer is B. My next video will be the most important in my whole series. I'll go through the one recipe I use to answer any A-level electricity question, and I use it every single time.